let's get this thing kicked off. Looks like might have a couple more trickling in, but let's get this thing rolling. Hey everyone, thanks for hopping on with us today. Sorry, I'm out on the road as I always tend to be, and I'm in my you know, good old favorite state of Illinois. So in the rain, but excited for the topic that we've got here today. This is part of our webinar series here at Continuum Ag. Wanted to share some insights, especially about cover crop management. Of course, tying in things into carbon intensity, but you guys will see as we go along here some of our thought process. I think is going to tie well, and I hope a lot of folks will really enjoy this recording. This is being recorded for anyone that can't make it live. It'll end up on our YouTube page, Continuum Ag YouTube page, likely the audio on our TopSoil podcast. So got a special guest with me here on the webinar today. This is Dr. Rodrigo Werle. He's with the University of Wisconsin, and we've been excited about having Dr. Rodrigo on. That Dad and I heard him speak at a conference at the Wisconsin Dells this past December, and was really impressed by his knowledge and his info. And Rodrigo, you'll have to share a little bit that I think you've been invited back there multiple times, and there's a reason for it. And I think everyone here is going to see that too, that you really know what you're doing, but making it practical too, right? And I think there's oftentimes kind of a disconnect between what happens at the university and what happens on the farm. And I think you've been able to really bridge that gap well. So wanted to have you on sharing, about cover crops, about how do we manage those covers, especially some of the utilizing that biomass. And Rodrigo, so how we approach cover crops or other soil health practices here at Continuum Ag is that these practices are offensive management tools, not just defense. That cover crop is not just to defend against erosion problems or defend against water quality issues, but that cover crop is an offensive management tool to cycle nutrients, fertilize and side dress the crop later on in the year, suppress weeds and decrease our pesticide bill, and now, improve our carbon intensity score. But they're offensive gains. I think that is really what sums up a lot of your work. But excited to have you here. We'll let you present. You've got some material and some findings. Everyone in the audience, feel free to put your questions in the chat. We'll make sure that we get to those. I'm sure I'm going to have plenty of them as well, but jump in with those questions. But Rodrigo, appreciate you taking the time and sharing some of your thoughts and expertise with us here today. We'll let you take it away, but maybe introduce yourself, and the floor is yours.
Yeah, no, absolutely. So first of all, good afternoon to those that are joining us live. It's an honor for me to be here. Thanks for the invite. Mitchell, as you said, we met during the Cover Crop Water Quality Conference at the Wisconsin Dells here. It was a very impactful conference last December. Truly enjoyed your presentation and truly enjoyed talking to your dad too. Your dad and I, after some of the presentations, we sat together for some of the roundtable discussions. I learned a lot during the presentations, but the discussions that I had with him were very, very impactful. And your dad was discussing with me, the value of extension, the importance of extension. And I think you brought some really good points there. And, what I try to do for our work here at the University of Wisconsin, our Cropping Systems Weed Science Lab, is we do research that we want to publish, but the research that we do, first and foremost, they have to be relevant to our growers. Yeah. So we always have the grower in mind. Every single research plot we put out there, we have the grower in mind. How is that going to help the growers? So that's been the focus of our program here at the University of Wisconsin for the past 6 years. So we have the grower in mind, and then we're also training the next generation of agronomists and farmers. So we want to make sure that the next generation is also very well connected to the challenges, to the reality, and to all the great things that our industry is doing out there. So that's been the focus of our program. And I think it has helped us in tremendous way to stay relevant. And that goes back to the discussion that I had with your dad. We got to stay relevant in this DNA. There's a lot of information coming from a lot of places, and we're trying to stay relevant. So again, thank you for having me here today. Yeah. Thanks to all those who are online. As questions come in, we'll try to address. Usually I come data heavy, So for this discussion here today, what I have only 2 data slides, if you would, and then I have some images that hopefully will help convey some of our findings and some of the challenges with the systems that we are working with. So without that said, again, Mitchell, thank you so much for having me. I will start with this, right? I'm a weed scientist. Okay,
Yeah.
so I'm an extension weed scientist. I cover weed management primarily in corn and soybeans. And we have some challenges out there. And the first one, the biggest one, is in front of us here. Is herbicide resistance and is Waterhemp. I assume we have a lot of farmers from Iowa here, perhaps farmers from Wisconsin, Illinois. Waterhemp is the most problematic weed out there. We're struggling to control this weed post-emergence, as you can see in this image. This image comes from our research plots in a commercial field south of Madison. Okay, so this is the reality that the growers are dealing with out there. We're having a hard time managing these weeds, and we need other strategies, which is going to take me to the main point of the conversation here, which is the use of cover crops, right, Mitchell? You talked about using cover crops as part of offensive management. I really like the way you framed it, because that's what this is all about.
Yeah.
Cool.
Love it.
So again,
love it.
Yeah.
I think that's spot on, right? That in this, we have to have a biological approach and a chemical approach, right? And they work together. It's not a one versus the other. It's you can have both. And now some farmers have a mechanical approach as well, right? Especially with tillage. And obviously the mass majority of our farmers and farmers on this webinar today don't necessarily want to use that mechanical approach, but a biological approach and the chemical approach together. I think that's where we're going to have to continue to go more that route. So it's great. Love it.
Yeah, and that's pretty much the message that I want to convey here today. Chemicals only won't do the trick. Cover crops only. Cover crops can help, but alone, they won't control all the weeds. So it's all about integrated strategies. So Waterhemp is a big problem here in Wisconsin. We have giant ragweed also as a big problem. You go in other states, further west, kochia is problematic. You go further east, you have common ragweed. We have horseweed. So different parts of the Midwest will be struggling with different weeds. I think Waterhemp is kind of the common one across all of them. And good news here, there are integrated strategies that can be very, very effective on Waterhemp. And that's what I'm going to be focusing on today. So this is the slide here, okay? Historically, when you go talk weed management, you start asking, what is grower doing? What is the grower doing? What's recommending? The main things that come to mind is herbicides, right? Let's talk about herbicide programs. And this past couple of years, I decided to change that a little bit. I still talk a lot about herbicide programs. Herbicides are the foundation for weed control, but our herbicides need help, okay? For about 30 years, every 3 years, we had 2 new sites of action coming to the market, and that was between the 50s and 80s. Since the 80s, we haven't had a new site of action, and we're losing some of our site of actions due to resistance. So we need to bring other forms of management, okay, to help us maintain the herbicides that we still have in our hands that are still working, okay? And this is where I think this integrated approach is very, very important. 2 strategies that we're going to be discussing here today. I'm going to show some data and some images is, row spacing, which I'm going to discuss in a little bit, and cover crops. Cover crops, when properly managed, can really help with weed control. And then we're going to get to that in a minute here, Mitchell. But first, as far as chemicals go, I think the foundation here, for many, many years, we were able to control weeds with post-emergence applications, right? We had the Roundup Ready era. We relied exclusively on glyphosate post-emergence. Glyphosate was phenomenal for 20 years. We didn't need anything else, right? Now we're using glyphosate. We're using 2,4-D, choline, or Enlist 1. We're using the dicambas. We're using Liberty. And yet, we're not getting full control of our weeds. Okay, so as far as chemical selection goes, the best way to start is through the selection of an effective pre-emergence herbicide program. Okay, so when we're controlling weeds, especially Waterhemp, we need to be using good pre-programs. And I always urge our farmers and our agronomists out there to take a close look at their programs. It's not just a matter of putting the pre out there. You got to be very strategic about the pre that you're putting out there. You want to be making sure you're putting at least 2 effective active ingredients together. This is what our research is showing us. When we put 2 actives together, either as part of a pre-mix or if we're making our own mixes, that's all cost-driven, right? Where you can get the best deal. But not only you got to put 2 AIs together, you got to deliver them at the right rate. because I'm seeing a lot of farmers that are putting multiple AIs out there, okay, and they're doing the right thing. The problem is that we're not putting enough, so we're putting a bunch of AIs at very reduced rate, and that's also very problematic for resistance. So when making decisions for this growing season, for the future growing seasons, when using as a residual herbicide, mix and use appropriate rates for your soil conditions. So that's kind of our number one recommendation as far as selection for herbicide programs go, because you don't want to be on the scenario on the left on the slide, right? Trying to manage all this water hemp post-emergence when it's all established is very, very difficult. On the right, look at that, a good pre-emergence herbicide. There are very few weeds at this stage. The grower has a little more time to trigger that post-application when it's truly, truly needed, okay? So I think we're all, familiar with this concept, but the whole thing is mixing and paying close attention to the rates that you're delivering.
Definitely makes a lot of sense. Now, but for a lot of the farmers on here, we're dealing with cover crops ahead of time, right? And so, on our farm, we don't use any pre-emergence at all, and we haven't for a long, long time. No, I'm sure I don't want to jump the gun, right? And I'm sure you're going to get to it, but I guess maybe thoughts on that, or is that, I don't want to jump the gun on thinking of that holistic system, but how do you address that? I guess for the farmers that are right off the bat thinking, well, I've got a cover crop out there. Can I still use this pre-emerge, or again, I don't want to jump to conclusions, and maybe you're going to get to some of that later, but thoughts, I guess, on that notion.
No, I'm really glad you're bringing that question up. I think that is a phenomenal question. I get the question a lot. So when can I stop using a pre and just go full throttle with my cover crop biomass as my pre program? I think what you got to evaluate is if you have water hemp, and if you have good infestation of water hemp, and you don't have a uniform cover crop stand, you're still gonna need a pre-emergence herbicide for good control. Now, if you're doing this for many, many years, water hemp is not a troublesome species in your operation, you're dealing with some other species, then I think you can. There's an opportunity there for taking that pre out. But again, if you have resistant water hemp, heavy infestation, if you don't have uniform cover crop stand, that pre-emergent herbicide is still going to help you. And I'm going to show you a slide on that. Mitchell, please bring that up once we get to that slide.
I think that piece is really, really important there too, right? And as we think about the cover crop as part of that offensive management system, if you don't have even coverage, if you don't have good control, it's not going to work. It's not going to get you that outcome that you need. And you're going to have to rely on the chemistry if that biological lever isn't there to its fullest extent to get you those gains. So if you plant your cover crop too late, or you don't let it get big enough in the spring, or whatever that case may be, I think that's really, really important. That it's sometimes as farmers too, I think we got to kind of cut our losses a little bit and utilize the tools available in the toolbox to avoid headache and issues down the road, because they're just going to compound, right? If we let the weeds get ahead of us, it's going to be more costly and more detrimental to fix a bigger problem versus addressing one small.
Absolutely. And then again, it goes back to your offensive management, right? It's two strategies combined, they're out yielding either alone. That's what our research is telling us, always combining them. And again, remember, when we're doing this research, we're going up against scenarios like the one you see in this picture here, right? Which is kind of the worst case scenario. So it's a very valid point, and we're going to come back to that. So I'm thinking here programs, okay? So we think about our herbicide programs. We're talking about residual herbicides for water hemp control. Our farmers are aware of that. What I'm thinking here, I'm trying to build a program where we can use cultural practices to supplement our weed control programs, okay? Farmers ask me, Rodrigo, what else other than herbicides can I be doing? There are two things. One thing is going to help them mid-late season, which is what I have right in front of you. And then the other one, which I'm going to spend the rest of my time discussing, is going to help you early season, which is the cover crop biomass. Okay. So for mid-season weed suppression, late season weed suppression, what I tell farmers is if you're really concerned about the weeds, if you're struggling with your weeds, we need to revisit our systems a little bit. And I'm thinking particularly soybeans here, okay? Because there's a lot of work done in soybeans. Soybeans where we're having a hard time controlling weeds post-emergence. So what I tell our growers is changing your row spacing can be a very effective strategy. More than 70% of my growers here in Wisconsin, they plant their soybeans on 30-inch row spacing. Okay, and that's the equipment that we have for corn. I understand the logistics behind it. The problem with 30-inch soybeans is that they never canopy. Okay, so these beans were planted late May. I'm taking these pictures here early July. The picture on the left is 30-inch scenario. The picture on the right is 15-inch scenario. Okay, this 30-inch scenario, we walked there 4 weeks later, it was still not canopied. The scenario on the right, 10 days later, it was fully canopied. Mid-July, fully canopied. Okay, if you have a scenario on the left, remember Waterhemp, here in Wisconsin, Waterhemp starts germinating second, third week of May. And we did a study last year. We had 17 weeks emergence window of Waterhemp. So as long as your crop is not canopied, that Waterhemp continues to come through. So putting your crop to work for you, it's important. And one way to do that is change your row spacing. It doesn't have to be everywhere. The common question that I get, Mitchell, is, Rodrigo, I don't have a 15-inch planter, but I have a drill. Would that work? Say, absolutely. And you don't have to go across your entire farm. You can go to the fields that concern you the most, or to your field margins where Waterhemp is usually more problematic. You can use the site-specific concept here. Our growers have this equipment. If they deploy the equipment that they have, the strategies that they have in hand strategically, they can really help better manage weeds in their farm. Okay, so the row spacing is something that we got to work on, especially in the areas that we're struggling. 30-inch row spacing takes forever. Those two pictures here is same seeding rate, same planting time. The only change is from 30 to 15-inch, and you buy 10, 15 days of extra weed suppression from the crop when you go narrow. And then there's this work that just came out of the University of Nebraska-Lincoln. What they did what we call meta-analysis. They looked at 30 years of research, Mitchell, and what they learned is narrow row spacing. Anything narrower than 30 can be 20, 15, 10s, 7.5. Narrow row spacing in soybeans suppress weed density by 42%, weed biomass by 71%, and increase crop yield by 12%. Okay, so oftentimes when you're going narrow, sometimes you're getting the same yield, but sometimes you get a slight yield bump. And as a grower, okay, there's investment on the equipment, okay, but if there's a slight yield bump from changing this practice, I'm getting better weed control, and I might be getting a slightly higher yield. That makes sense, right?
That's awesome. And Rodrigo, so, we've been no-till drilling soybeans every single year since 1986. And a lot of other farmers, especially in our neck of the woods, Washington County, Iowa, a lot of folks using that and absolutely seeing exactly as you're talking. Now, question though, part of this weed suppression, what is it actually like doing to the plant? And what I mean, and why is it actually working? Okay. Part of my understanding is that canopy is helping to keep the soil cooler, and water hemp needs hot soil conditions to germinate. Is that the majority of what we're seeing here? Is that am I off the reservation there? Is that part of it? Is that not? Are there other things? Maybe explain a little bit more, like, why is that canopy actually suppressing weeds, and does that temperature component have something to do with it?
That is a phenomenal question. I'm going to talk a little more on that in a little bit, but since you're asking now, so why? No, it's a phenomenal. I love those questions. So I always thought it was light. Okay, response to light. I thought water hemp seed was responding to light. We've dug through the literature, and we did a lot of work here. And light is important, but light is not the driving factor. What happens is, if you have a scenario like the one in the left, you have direct light hitting the soil, and it's just transmitting energy, right? Heat. So when you have light hitting the soil, we measure temperature. There's a tremendous temperature fluctuation. It gets really hot in bare ground. When you have either a cover crop or where you have your canopy closure, you're preventing light from getting to the soil surface. What happens is you reduce temperature fluctuation. Water hemp seed responds to warmer temperature and fluctuation together. So if you want to increase water hemp germination, you got to increase temperature, but just increasing temperature is not enough. You got to increase temperature and have wide fluctuation, because that is a sign for the water hemp seed that's close enough to the soil surface. Water hemp seed is very small, so it really responds to the temperature fluctuation. So again, light is important because light is what's gonna drive temperature fluctuation, right? But what's driving that emergence is the temperature, Mitchell. So you hit it spot on. And that's why
awesome.
either canopy closure or having heavy amount of biomass residue in there reduces average temperature, but also reduces temperature fluctuation throughout the day. So it tricks that water hemp seed not to germinate and emerge.
That's super cool. I'm glad that that backs up what I've been telling farmers for a while, because I have a slide where I'm telling farmers like there's got to be something to that. That one day I was out playing around, and some of the folks on this have seen that slide where we had terminated the cover crop, and it was a big, heavy, super thick biomass, and it was 90 degrees air temperature. At the top of the canopy was radiating heat. It was 100 degrees. At the soil surface where the soybeans were growing, 76 degrees. It's perfect. But bare soil on the edge of the field with no canopy, 126 degrees. And exactly to what you're talking about. But what's interesting here, and for everyone, why I'm jumping in on this, the fluctuation piece is really interesting. So it's not just that it gets hot, but the fluctuation, and that's absolutely, we've seen that with our we have temperature weather stations and stuff out in our fields, and we see more fluctuation where we have less ground cover. I mean, it's going back to mimicking Mother Nature, right? Mother Nature doesn't want flexibility. No, Mother Nature doesn't want this variability. Mother Nature wants osmosis and consistency. So very interesting that it's not just the temperature though, but the flux in
Yes.
temperature, incentivizing that weed to germinate and to go.
Yes, and then the other point that
Super
we
cool.
learned through that too is that because we don't have the minimum remains the same whether you have cover or not. What changes is that max. So we never get too high when we have a cover canopy there. But the beautiful part about the cover is now having that mat of a cereal rye cover crop. What we see is also moisture. Assuming we have enough moisture early on, once you have that mat, that moisture stays in there. Okay. Whereas if you don't have that crop residue on the soil surface, you tend to lose a lot of that moisture on the top surface. So if you're thinking about, quality of your soil health, everything that's living on that soil, minimizing those extremes and having this more comfortable environment, if you would really help your soil health in there, and it tricks, water hemp in this case, not to emerge. So I see that as a win-win.
Mm-hmm. Love it. Love it.
Okay. And then here's where I kind of go next. Mitchell, we talked about row spacing as a strategy for mid-season, late-season weed suppression, right? We want to help our herbicides. We want to have better weed control, so narrow row spacing can help. Early season cover crops can help tremendously, and this is where kind of my career with cover crops kind of start. This is during my time at Nebraska. I was there for graduate school, and I like to joke when I give presentations. This is where my accent comes from, right? I spent a lot of years in Nebraska, so I got a Nebraska accent. People, usually get a kick out of that. But Nebraska was a tremendous school for me. I did grad work there, master's, PhD in Lincoln, and then I worked at North Platte, the West Central Research and Extension Center, more in the western part of the state there, as a cropping systems agronomist for a year and a half before coming to Wisconsin. So I got to see Nebraska. I got to see one side of the state where you have plenty of rainfall, and then you go on the other side of the state where you have barely enough rainfall to grow a crop. So, learned a lot during my time there. But this is one of the demonstrations we put out for growers and crop consultants back in 2016. There's this interest in cover crop was starting to pick up slowly at that time. So we wanted to be at the forefront of this and demonstrate the value of a cover crop. So in this demonstration, here's a little extreme. But what we did in 2015, we had a winter wheat crop. We harvested that winter wheat crop in July. We worked the ground, we tilled the ground, okay, and then we put our strips of cover crop that prior fall. So we had cover crops that were not going to winter kill, and then we had cover crops that were going to die over the winter. All right, and then you fast forward about 7 months or so. May it is. We're here for this field day. The day before our field day, we had 6 inches of rain in 2 hours, and that's the result of that. Okay, so the no cover area here, kind of the more left side here, is where we didn't establish a cover the year prior, and you can see what happened to the soil, right? I mean, it's pretty visible. This was a 3% slope, 6 inches of rain in 2 hours. It's a disaster. All right, but then you look on the right, and this surprised me. We had a beautiful stand of radishes the prior fall, even though the winter killed the radishes. The soil stayed together. And then around it, the 2 plots, I had cereal rye that had been terminated a week prior, and then had cereal rye that was still alive. The soil was in place, But what I like to point out is the weeds, right? Remember, I'm a weed scientist. So you look at the amount of winter annual weeds growing in the area where we had no covers, where we had this cover crop here, there are a few weeds that escape, but here is much better than here. And then you walk around the cereal rye plot, you don't find a winter annual. So the cereal rye cover crop can be a very powerful tool for suppressing winter annual weeds such as horseweed or mare's tail that's giving us a difficult time. Okay, so that was the first thing. Then I come to Wisconsin. Waterhemp is our biggest problem here, right? And my question at that time is, can we use cover crops to help us manage waterhemp? And what I was told when I first came is, look, our cover crops here, we're too far north. We cannot produce enough biomass. And I'm a little bit of a stubborn dude, if you would, because if they tell you can't do it, right? I say, all right, we got to figure a way to do this. And there are ways you can do this. It's all about management. If you're managing your cover crop as a real crop, if you're properly selecting a variety, if you're establishing it timely, and if you're giving it enough time in the spring before you kill it, it can do the trick. And the beautiful thing is that cover crops, high biomass, cereal rye cover crop, and soybeans are compatible. You can plant soybeans into heavy stand of cover crop and have a successful soybean crop and also have a successful cover crop. With corn, is a little more complicated. Maybe your opinion is different than mine, but corn is a little more finicky. Corn, you got to be a little careful. You don't want to have too much biomass ahead of your corn crop. But soybeans, our research here, 4 years of work has shown that this system can be compatible. Yeah, there are some tricks, and I'm going to talk a little bit more about this, but it's possible. All right. And then you look at this image here, Mitchell. Left, this pictures were taken early July. Left is just bare ground. Right is where we brought different amounts of cereal rye biomass onto the soil surface, because you were asking me what drives suppression. Oftentimes we associate all that to allelopathy. Allelopathy might be part of it, but this physical suppression is what's happening. This change in the microenvironment is the main force for waterhemp suppression.
I think that's spot on. So on this example, it was the biomass residue that you brought on, or was it the living cover crop that was there that would have that allelopathic effect? Or was this just literally just residue, like a straw? You just spread straw.
Yep. In this case, it was just straw.
Okay.
Because if you think about waterhemp is usually growing after that cereal rye is controlled.
Yeah.
Okay. So what was driving this, it was actually the straw having that impact on the temperature on the soil surface, tricking waterhemp not to grow. And those that tried to grow, they had that mulch to go through, and it was very difficult to grow through that mulch. So it's not a perfect system. You see a plant that escaped here, but look, if you compare to the ones where there was no residue, it's day-night difference. Okay. So I think that impact that mulch has is very, very important.
Yeah. No, that's awesome. I think that's spot on. And so, too, you had talked on the planting into covers and stuff. And yeah, what we typically recommend is significantly easier to plant soybeans into a cover crop, especially cereal rye. We typically plant soybeans fairly early when the rye is small, and then we let the rye go all the way into reproductive mode before we terminate, or sometimes even relay crop it. We've roller crimped a lot of farmers on this call that have been working with us for a while. A lot of them plant green and terminate later. So, on our corn, we plant corn green as well. Now soybeans, we'll let that cover crop biomass get big, and we'll have 10, 12,000 pounds of live biomass out there. On corn, we'll plant green and then usually terminate a week or so after planting, before the corn emerges. Usually we have more diversity in there, usually a little bit lighter rates of cover, but still getting in that, at the most minimal stage, 1,000 to 1,500 pounds of biomass. When now we get more aggressive, we're getting close to 4,000 pounds of biomass with our corn crop, letting that cover get a little bigger, planting the corn a little bit later, utilizing, kind of strip till and stuff like that to be able to create a little bit of a space, but trying to change our planting system and trying to let that cover do its thing. But to your point, I mean, even where we're at in Iowa, we're far enough north where we don't always get a bunch of biomass out there in the fall. So it takes being patient, plant green, and then let the biomass continue to grow, while at the same time making sure that we get our crop planted when we want to get the big yield.
Spot on. I mean, I'm so glad you're sharing that, because that's kind of where we're going, where we've been looking at planting green, planting early, because that's a trend. Our farmers every year they're starting to plant earlier and earlier. But if you're planting earlier and you're terminating at the time you plant, there's not enough biomass. So then
Yeah.
we're defeating the purpose. So what we're trying, and I'm gonna have a picture. It's great because what
It's
we're
back to the
doing is
offensive.
yes,
It's back
yes.
to the offense, right? I mean, if my cover crop is so small or I'm terminating it 1st of April, that cover is so small, I'm not getting that offensive outcome that I want. And therefore I'm going to have to spend more money on herbicides because I'm not going to get the biological control or that physical control. I'm going to have to rely on chemistry. But one thing before you go on to this next one that I want to hit on for the winter annuals. So with the summer stuff, we were talking about not having that soil temperature get too hot and the fluctuation. Well, in the winter annuals, that wouldn't be the case. Why do we know why we're seeing some of the suppression of the winter annuals when they don't need? I'm assuming that they don't need the hot temperatures to germinate, right? They're winter annuals. So, do we know what the purpose would be and why they're being suppressed?
That's a really good question. As far as winter annuals go, we did some work on that as a direct competition. If you think about some of the winter annuals that are really problematic, let's think about horseweed or maristeo, for instance, which is a problematic weed across winter annual across the Midwest. It's truly a wimp when it's coming up. It's very weak and it's not competitive. The maristeo doesn't become problematic until it reaches the full rosette stage and it bolts in the spring. So if you have a cover crop, a rye cover crop that can take off faster, it pretty much chokes that maristeo out of the game. So if you walk the fields in the fall, you will see both growing side by side, and you track those plants. The cereal rye takes off, and then that horseweed plant is going to die because there's no light getting to it to allow it to continue its growth. So it ends up being choked by the cereal rye cover crop. And that's why I like folks ask why cereal rye. The reason why I like cereal rye is it responds to your springs, right? As you said, if you're planting a little later, don't expect biomass in the fall, especially after corn and soybean harvest. There's just not enough time. Sometimes I talk to my growers, the ones that are starting to do cover crops now, and they get frustrated because they think they're going to plant after harvest and they're going to see a beautiful stand of a cover crop. It doesn't happen. The magic happens in the spring if you're patient and if you did a good job establishing the cover crop in the fall. And that's where that rapid takeoff of rye comes in and just helps suppressing the winter annuals. And even if it doesn't suppress them completely, if you walk your fields there, I bet you in the spring, if you have horseweed, you will have a few in there, but they're going to be very weak and they're not going to be setting a whole lot of seed. And when you do your burn down, assuming you're using, glyphosate or something to burn down, you have tremendous opportunities to eliminate those winter annuals. And the same is true for large seeded broadleaves such as giant ragweed that might be growing that weren't effectively suppressed by the cereal rye. You have opportunities to manage. So that green, actively growing cereal rye cover crop directly suppresses through competition your winter annuals. And then you have to have enough biomass, enough residue to then suppress the late season summer annual weeds such as Waterhemp. So that's how it works. It kind of is a two mode of action, right? It's a contact product, but it's also a residual product if you think it that way, a foliar and a residual.
That's awesome. It also makes me think just one quick piece for farmers that are having those issues, maybe even looking at an Elbon cereal rye that comes out of dormancy just even a little bit faster. Now, further north might not be quite as good, but in our neck of the woods, Elbon rye has been phenomenal. It really comes out of dormancy even faster, get that quicker takeoff, quicker growth to get that direct competition even faster. So another anecdote, but that's awesome. So good stuff.
Excellent. And then you brought up a good point. Varieties, I wasn't paying attention to varieties when we started our research here at the university. We just thought rye was rye, right? But then we started playing with different varieties of rye, and it's amazing how the different varieties respond. So there are early maturing varieties out there. If you want to have high biomass ahead of soybeans, I recommend those early maturing varieties. If you're going to have corn, maybe you don't want that rye to be as aggressive. So maybe having a late maturing cereal rye ahead of corn can be helpful. So there's like management strategies, there's agronomic knowledge that we need to have as far as selecting those cover crops as well and putting them to work. But this picture that I have in front of you is just a scenario right here in Wisconsin, southern part of Wisconsin. When to terminate, right? That's the question that we have from growers. Say, hey, I don't want to go on the right scenario. I know the right scenario is phenomenal for weed suppression, but my equipment, maybe I don't have good equipment to plant into that. or I'm concerned about moisture. 2023 taught us a lot. If you have rye like this, you probably lost a little bit of yield. That's what our trials showed us. Anything that was terminated probably a week before we got to this stage, no problem, Mitchell. But anything that was fully headed out, it's a biological system. Once the cereal rye is fully headed out, is a water pump. In wet years, let it go. But in dry years, it's sucking the soil profile. So again, just pay attention to that. So, but the question here is when to terminate. And here we have some data. This is some of the data I'm going to show you today. So on my x-axis here is the cereal rye biomass, the amount of cereal rye that we need, dry matter. And on the y-axis, the number of water hemp plants we needed to control post-emergence. This is 5 site years of data replicated, really good stuff here. But what's showing us is when you just have a little bit of rye, when you don't have enough, let's say about 1,000 pounds of rye, if you walked a field that has about 1,000 pounds after you terminate, there's not enough to cover that soil, but there's just enough to kind of keep a little bit of extra soil moisture. And that extra soil moisture actually stimulates water hemp emergence. So very little biomass can be problematic. But once you go past that hump, once you get into the 3,000 pounds onwards, then you're seeing tremendous suppression. The number that we keep talking about, Mitch, is this 4,600 pounds, okay, 4,500 pounds. Rodrigo, I'm a farmer. I'm not measuring dry biomass. What the heck are you talking about? So in order to get 4,600 pounds of dry biomass, you want to kill the rye when it's at that mid-tie, a little above your knee, about mid-tie, 30-inch rye. Okay, so let's put here about 30-inch rye. That's about my mid-tie, if you would, 2.5 feet. Your row spacing for your corn. That's the height of that rye. Once it is at that stage, it's going to provide tremendous weed suppression. And in all the research that we've done, when you have mid-tie rye, 4,000 pounds, it's still easy to plant into, assuming you have decent no-till equipment. And usually the moisture is not too big of a concern yet. So again, tremendous weed suppression. You're reducing your risks, all right? But here, what I'm talking about to you, Mitch, is that scenario where we were before, where we waited for the rye to get to that stage and then plant. I think we got to change that mindset, and I'm going to show you some data in a little bit. We don't want to miss that early window. That early window is beautiful to plant, okay? We're going to come back to that. But what the research, again, is telling us, 4,000 pounds provides 50+% suppression of water hemp, and that's phenomenal, okay? So that's what our work is showing us. Why? That question you asked. You have that residue on the soil surface is blocking light, okay, is reducing temperature fluctuation on the soil surface, is tricking that water hemp seed not to germinate. And those that try to germinate, they're going to spend a lot of energy going to that residue. So they're going to be weaker seedlings. So even when you have those plants coming through, it's easier to control with any post-emergence chemical program you might be deploying on your farm. Okay, so this cover crops, again, can really help us achieve better weed suppression in our operations. The one question that you asked before is the pre-herbicides, right? And I think I use this image here from our PhD student, Jose Junior Nunes. He just finished up. He did a phenomenal amount of work on this. I'm very grateful for all the research that he did. And most of the research that he did is not only Wisconsin. This is the beautiful part. We're funded by the United Soybean Board, and we had 12 states. So I can guarantee that all folks on this call here, their states are represented behind the data that I'm talking. So it's multi-state research. It's summarizing findings, not only from Wisconsin, from all over the Midwest, which is beautiful. But one thing that we're learning is the more biomass we have, the more interception of our pre's. So if we're waiting a lot to spray a pre, we have really tall rye, a lot of that is going to be intercepted, may never make it to the soil if you have excessive amounts. And at that point, Mitchell, back to your question, then you don't need to spray if it's never going to make it to the soil. But if you're spraying this 4,000 pounds, which I'm going to show a picture, there's still good amount that's going to go through. So this is what happens. You spray, right? And then you got to hope for rain shortly after that application. So the rain is going to wash. But not all herbicides are going to be washed equally. And this is where our next research is going. We want to know the herbicides that are more compatible. Because if a farmer is spraying $20 on top of their rye, we want those $20 to be down in the soil controlling weeds. Okay, so we're trying to find herbicides that are more compatible when they're needed in the system that are going to make through. Okay, so that's the next phase. So folks that are very interested in this concept type of work, stay tuned. For instance, we compared sulfentrazone and metolachlor, so Spartan and Duo. We learned that more Spartan makes through the residue than Duo. Duo is a little less stable as far as exposure to sunlight goes. And Duo is less soluble, meaning it needs more water. So Fentrazone is more sunlight stable and it needs less water, so it's more likely to be washed.
Mm.
Metribuzin is a herbicide and doesn't need a lot of water, so it's more likely to be washed. So we're comparing all these common herbicides that we have at our disposal to see which ones are more compatible. Because we don't want to spray and have the herbicide hanging on our residue. We want whatever we're spraying, we want it to make it to the soil, right? Because we don't want it to be like sitting on top of a cover crop, 30-inch of gas and moving away from our applied areas. We want it to go there, control the weeds, and stay there. So that's where the next phase of our research is going, Mitch, which is fascinating and I think has gotten a lot of attention from agronomists and farmers out there.
That's really interesting. And Dad and I were literally having that exact conversation on Friday about how we don't really use any residual herbicides anymore because we don't have soil exposed. We're like, well, most of it's going to be caught unless you can guarantee that rain. But I mean, the rain that we're getting today is by far our biggest rain in over 15 months. So now maybe we're going to get some of the rain and be able to do exactly like you're talking. But like we're seeing is, yeah, if we're not going to get the soil based residual herbicides to the soil, we're just kind of wasting some of our money. Another quick thought too, so I don't forget, on your previous stuff, you were talking the 4,600 pounds. I think on my mind, I'm like, oh man, that's kind of a lot of biomass ahead of my corn, right? Or plant my corn and then let it get big. I'm sure a lot of other farmers thought the same. But I think where my head goes to with that is what we teach farmers, which is in the soybean year, let the cover crop get really big and really hammer on the weeds in that year, because on your corn year, you might not get 4,600 pounds. I think most of the time ours, if we're talking 30 inches there, sometimes our cover crop ahead of corn gets, or on a corn year gets to 30 inches, but usually we're killing when it's more like 18 to 20, 24. So we're getting part of the control from the cover crop, but because the biomass was so big the year before on the soybeans, I really am suppressing the weeds then, working those seed banks down to therefore not have to be as aggressive on my corn year to be able to get away with some of this stuff. And then again, not utilizing the residuals. We don't use residuals at all on soybeans because there's so much biomass that we'd never get bare soils. But sometimes on a post-emerge herbicide, if we don't have the biomass out there ahead of the corn, that sometimes we'll have enough soil available that once while there we could use a small amount of residual herbicide. But just to continue to back up exactly like you're talking, we're absolutely seeing that, but it takes time, right? I mean, we've been using these cover crops for about 10, 11 years now, that it takes time to work those seed banks down and get to the point where you can utilize less. But really interesting to, especially farmers, think about this as that cover crop takes off here. We've got moisture now, we've had some heat, these cover crops are going to take off. And yeah, if you spray a herbicide, make sure that you've got the moisture to get it to the soil if it needs to get on the soil, or might have to change up the program.
You brought up a phenomenal point. Thanks for clarifying that. When I'm talking this 4,000, 5,000 pounds, I'm talking about a head of soybeans, right? In your soybean year. In your corn year, the number you described there, 18 inches, 20 inches, 2 to 3,000 pounds. That works really well ahead of corn without impacting yield. So exactly, you don't need as much biomass ahead of your corn as you need ahead of soybeans, because soybeans where we usually are struggling the most. And then in corn, we have some alternative options. And again, it's thinking about that rotation system, helping, putting that rotation to work. Because if you crash the amount of weeds in your soybeans, you're going to have fewer weeds in your corn, and you don't have to go too high of a biomass ahead of your corn to minimize some potential yield losses. So thanks for bringing that up again. So high biomass is for soybeans. So
that brings in real quick, maybe Dennis's question from the Q&A, and
yeah.
Folks, as we're Rodrigo and I are just having fun here, obviously.
Oh, man.
So we're already most of the way through, but we could talk on this, I think, for probably another couple hours. But Dennis is asking, are there any resources about like some of these herbicides, like which one would work with cover crops, or like you would just gave like this one herbicide versus the other ones? Is some of that out there and published, or maybe you can get some, maybe you're going to get to some of that, of some resources where people can find some of this info?
Yeah, absolutely. No, we have it on our website. We just put a publication out recently talking about this. I will put in the chat here before we disconnect. I'll make sure, if I forget here, Mitchell, please remind me to do so. But everything is in our website, whiskweeds.info, and we have a recent one where we discuss this topic in particular. We don't have data on all the herbicides yet. This is where actually we're starting research this year. We have a new graduate student that's going to be looking at 12 different herbicides in soybeans, how they wash through residue and so on. So stay tuned on that. That's a big part of our efforts this year. But we have a pub that we just put out, and I'm going to share here before we end this conversation, and maybe you can send to them later as well, Mitchell.
Yeah, you bet. Yeah, or Diana, maybe you can help us out with some of that too.
Awesome. And then here are pictures, right? So on the left here, sometimes they talk about 4,000, 5,000 pounds. When I bring those are big numbers, right? And then farmers or folks that are not as familiar with covers, they think, I'm talking about a cover crop as tall as I am. And actually, again, back 4,000 or 5,000 pounds, that's your mid-tie, right before that rye is getting ready to head out. Remember, when is at that boot stage, putting the seed head out, this is when it has a pretty high CN ratio. It's going to take longer to decompose, and that's the catch. You don't want to queue before it reaches reproductive stages because that CN is low, the composition is fast. So you want that cover crop to get to those reproductive stages, boot stage, starting to head out, because that's when you're going to have a residue that's going to last for a couple of months, and that's very important. Okay, so the scenario on the left here, we're spraying 4,000, 5,000 pounds. We have heavy water hemp pressure. In this scenario, I definitely recommend putting together a pre-emergence herbicide, because you're still seeing the soil, we're seeing the soil there, but the cover crop is going to help you tremendously with suppression, okay? But it's still helping, okay? The residual herbicide is still helping. Now you got a scenario on the right where we have 10,000 pounds here. Nothing is going to go through. That cereal rye, there's excessive biomass in there. No residual herbicide is going to go through. So if you're in a scenario like that does, like this one right here, I don't know if you can see the cursor there, Mitchell. In a scenario like this, it doesn't make sense spraying because nothing is going to go to the soil. Jose collected data on this. Less than 10% of what we sprayed here on top actually made it to the soil. So at that point, it to me doesn't make sense, because you're getting tremendous suppression from this, and the residual herbicide is not going to be able to travel through. So here, yes, absolutely. If I have Waterhemp, if I have this amount of cereal rye, I still support the use of a pre-emergent herbicide. In this scenario, we can change our program.
Mm-hmm.
All right, some things to watch for that our research has shown. We can plant grain, okay? We've done this 18 site years, 12 states. 70% of the time we saw no yield reduction compared to straight no-till. So planting grain into heavy biomass versus no-till, 70% of the time, no yield reduction. 30% of the time we did see yield reduction. Our grad student, Jose Nunes, what he did, he dug through the data, and the only correlation that he's found to justify this yield loss was crop stand. So every time we didn't have proper crop establishment of our soybeans, we lost a lot of yield. I know soybeans are very forgiving, but they don't seem to be as forgiving in these heavy biomass systems. Where we didn't have the planter well set up, which you see here on the left, it was kind of a wet year, enough moisture there, but we couldn't get the seed in the ground. My research technician, Ryan DeWerf, the day he was planted, he was not happy. He knew this was going to be bad, but we needed to do the work. So we did it. Let us make the mistakes, right? We made a mistake. Our planter was not set up. The seed was staying on the soil surface. We had drastic stand reduction. We had drastic yield loss. Last year as well, where we could not plant into moisture because of how dry it was, we did not have even emergence. We lost yield. But all the years when we're terminating that cover crop timely, our equipment is well set up, and we can plant into moisture, assuming the soybean can emerge. Once the soybean is emerged and you have good stand, the chances of maximum yield potential are there, okay? So that's what we've learned through our research. We lost yield when we did not have a good early season stand of our soybean crop.
Mm-hmm. I think we see the same thing, right? And that's why I like typically planting the soybeans into, or planting any of our crops early when the cover crop is smaller, because it's a lot easier to plant into. Also, so, we typically recommend really light rates of cover crop, like ahead of soybeans in Southeast Iowa. Usually we're only planting our cover crop at about 40 to 50 or 55, 60 pounds of cereal rye per acre, to also not have too much biomass there. Because even in your picture on the left, so shallow, well, gosh darn, there's a lot of biomass right there. And it's big, stemmy biomass too, that absolutely would have been keeping that planter up out of the ground. And I'm assuming you guys don't quite have a 40-foot wide planter that you're planting these plots with. So not necessarily the heaviest piece of equipment, right? To push that seed, push those openers down and really get through. But when we're going into smaller cover crop, a lot easier ride. and then can terminate later. Just opens up that window a lot better. So yeah, so for farms that are on, we've seen this exact thing on our farm, but really trying to avoid it by planting a little bit earlier when the cover's small. Not quite like this. We've done some of this in
Yes.
this picture. We've done this, but definitely on soybeans works totally fine. We've done it on corn and had fine success there too. But really like planting early, then let the cover go, and still get the cover crop to be this big, but we like planting earlier, just a lot easier.
Yeah, no, when we started, this is kind of what we were doing, right? This is very heavy biomass. We're talking
Yeah.
8, 9,000 pounds. This is challenging. This is where the research is going, Mitchell, just like you described. Instead
Yeah.
of planting green, we're planting green and early. We're going early. And
Yeah.
what is your goal as a farmer? My goal was to put some biomass. I'm going to program. There's incentives. I'm putting that cover crop. I want to protect during the months that I don't, but I don't want to have risk on my crop. If you're one of those farmers, you plant early. This is what most farmers are doing across the Midwest. Optimize the yield potential, right? But you don't want to have risk. Maybe you terminate at this point. Myself, as a weed scientist, I want to see a little more biomass. I want to see this, right? How do we make this early system plant works? What you do, you plant early. Okay. Here's an option that you have, because you got to be strategic with your pre-herbicides, because if you're planting early, certain herbicides can only be sprayed within 3 days of planting. So you could deliver a pre-herbicide if you're planting early. I'm talking about
Mm.
April here. There are herbicides that will not hurt the cover crop. But remember, you got to take the glyphosate out of the tank, and then you're going to come back with the glyphosate as a separate trip when you meet your goals. Okay, so you can either deliver your pre now, or you can just plant, and let's figure this out later. So this is the new version of the study. Planting green and early is easier to plant. You can spread your workload, and you can optimize your yield potential. What we're learning is that the chances of losing yield because of poor stand in an early planted system is reduced compared to that late scenario. It's a lot easier to make this successful. So here's some data. Okay, 7 states. We've done this research. So we planted the beans as early as we could. So let me just put in perspective our Wisconsin scenario. Last year was April 20th. It varied a little bit from state to state, but overall, this early planting is usually in April across the Midwest. Okay, so if we plant and terminate 2,000 pounds of biomass at that time, Mitchell, am I happy ahead of my soybeans? Do I have my 4,000 pounds? Not yet.
No, no.
So I planted, and instead of killing the rye that day, I let it grow. I let it grow until the beans germinated. Okay, it's about 7 to 10 days there. At that point, I had 3,000 pounds. I'm not quite happy yet. Instead, I waited to kill the rye until my beans were at VE, and I'm talking VE at all sites where we did this work. That's another 10 days. Now I have 4,000 pounds. Now I'm happy. So I planted early. I didn't queue. I waited until that 4,000 pounds. Last year, that's the time I would have queued because we were dry. Okay. If you have more precipitation in the spring, you can let it grow another week, get to that 5,000 pounds, tremendous weed control. Okay, so this is what's happening with the rye biomass at the time of termination. The growers ask, what about yield, Rodrigo? Here it is. So if you terminate early, this is our yield potential there. Terminate a
Yep.
week after, not impacting yield. Terminate the VE is not dropping my yield compared to the check. I can go and terminate up to that VC, 5,000 pounds, easy to plant into, not impacting yield. Now, if I let it grow a little more past, last year was dry, 6,000 pounds, too much competition with my soybeans that are already established and growing because they were planted early, then we start losing yield. Okay, so the beautiful thing here is that you can plant early, and you can let that cover crop grow for up to 3 to 4 weeks until your beans are the VC V1 stage, and then terminate. VC stage, fully emerged, and then terminated then without impacting yield. But you got to be Johnny on the spot there. You got to have access to the rig, because a week passed, then you're going to lose about 20, 30 bushels. Okay. So if you're doing this, you got to have control of the sprayer. So you terminate the rye at the right time. And that's critical.
So we're seeing that we don't lose yield even going later, but you kind of brushed through the reason why you saw it, which was it was so dry last year. Which last year we solved some of that. We've been planting green, and there's a question in the chat, and I think you just answered it from a test about the yield loss, where you have the moisture, at least in our experience, and I want you to respond, but where there's a lack of moisture, we see this type of yield loss, right? Where the rye utilize the moisture, and we can see some yield loss. But where we have the moisture, we let the cover be the offensive management tool to manage and allow for the soybeans to have the right amount of moisture because we don't want them to have cold, wet feet. And we're seeing phenomenal yield, consistent, like 70 bushel type whole farm average, 69 bushel whole farm average yields, significant yields where we don't terminate until a lot of times those beans are way beyond V3. And then there is a question in the chat about harvesting it. We've done relay cropping. This will be our 6th year doing relay cropping where we don't terminate the cover crop at all. Instead, we harvest the rye over the top of the beans. And except for last year, which your data and mine is in alignment, where we didn't have the moisture, we lost some yield. We lost about 10, 15 bushel yield in our relay crop last year. But every single other year where I have the moisture, my average yield loss where I harvest the relay crop, the average yield loss is only 3/4 of a bushel from our regular soybeans. And in our multi-year trials, we're seeing that, especially over time, where we plant green, where we have cover crop versus no-till soybeans, we're actually seeing better yield where we have the soybeans and we don't terminate at all until they start dropping pollen and the rye is going into reproductive mode. Or like I said, we take it all the way to harvest. But maybe speak to that real quick, and then we're running out of time already. But speak real quick to that moisture piece, because like the yield loss here is where it was really dry. But do you have some of the data where it is wet, and does that change this graph?
Yeah, no, this trial we started last year, so everywhere where we did it, it was dry. So we have data out of a drought year. We're going to replicate this same effort, 11 states this year. So we'll see what the story will be. One thing to keep in mind, Mitchell, is that you said you go a little lighter on the seeding rate, and you probably planted your cover crop a little later as well. This was a very aggressive scenario. So that soybean, it goes back to the critical period of weed removal. That soybean, once we passed that V1 stage, that cereal rye was too thick for too long, too uniform. Yeah. That was choking the soybean. So we realized, because we started seeing the soybean seedlings getting spindly, they were starving for light. Okay, so in our scenario, it's a very aggressive scenario. That's why it did just well into the VC when it was relying on the energy from the motor plant. Still, once it started having to capture its own energy, it was having a hard time because the rye was too aggressive. In our scenario, it was closed.
That's spot on to what we're seeing too. The light rates of cover crop, planting the beans early, we don't end up getting those spindly plants. They are able to compete. That's a really, really good point of clarification. One of the we're out of time, and I'll let you wrap up here. And Dennis, we didn't really hit on planter stuff. Happy to have some discussions on that later. And then on VC, yeah, you'd be running over some of these beans, right? And no matter what, when you drive out here, were you killing some of those beans wherever you ran over the beans, or did that not really matter based on the timing?
It didn't matter for us. It didn't matter in there because we never ran over damage. Oh yeah.
Okay. Anything to wrap up? We're at the top of the hour, but any final kind of things or a couple last slide or two?
So what I'm going to do here, no, that was it. For me, I have my contact information, perfect timing. So I have my email there. Folks that are on Twitter, now X, if you want to look us up at Whisk Weeds, everything that we do, we share in there. And we have a lot of information on our website. So if somebody was asking about the publication, what I'm going to do real quick here. So let's go www.whiskweeds, whiskweeds.info right there for you. This is our website. If you come here to a research report, somebody asked about cereal rye cover crop herbicide fate. We have a beautiful publication that just came out on the same topic. I'm going to copy this link here. I'm going to drop it in our chat for those that can do it. But you just learn how to go to our website there and collect information. So here we describe what happens with the pre-herbicide in the environment when you spray it, how we collect this type of data in the lab. Okay, some of the faith parameters that you got to consider when selecting a herbicide, and then what happens with concentration, weed control, and so on. So really rich publication put together by our PhD student, Jose Junior Nunes, that's available to you all. So I just wanted to share that resource.
This has been really, really good, Rodrigo. Appreciate you spending the time. Everyone, I put that it should be in the chat there. Diana will get in the notes and stuff too. I think so much of this to wrap it up, right? That cover crop, as it ties to carbon intensity, cover crop is really important, but so is lowering your pesticides, lowering your fertilizer input. I have so many more questions about C to N ratios and nitrate, nitrate versus organic nitrogen. We're probably gonna have to I could obviously ask you a question for a long time. We didn't even get Dad in here to ask his question. I know he could. Yeah, I know you guys could talk for hours on this too.
Oh wow.
We might have to do that. We might have to do that sometime. But really appreciate you spending the time here. Really, really interesting stuff, and just in alignment with what we've been seeing at across farms at scale. But just to have a little bit more of the reasoning of why we're seeing what we're seeing, that I think was just awesome. So appreciate the work you guys are doing. We'll have to definitely keep in touch and compare more notes here at some point soon. But thanks for taking the time here today.
No, absolutely, Mitchell. Keep up the great work out there, spreading information out. I'm really glad to hear from you. You know, you're adopting this practice. You've been at the forefront, and it makes me very happy to talk to you, talk to your dad, and
Yeah,
learn that what we're learning, in our small plot work is also being validated by the farmers
that's
out
right.
there. And again, explaining the why. Your dad was like really enjoy listening to whys because he was seeing what I was trying to convey to him in my presentation, but says, you explained the why to me. I didn't have the why. I knew it was working
Yeah,
or not, but I didn't have the why. And this is great. So thank
that's
you.
exactly it. That's exactly it. Love it. Thanks everyone for joining us. This will be up on YouTube soon. We got more webinars to come, and especially as we think about managing our covers here this spring, whereas more farmers are going to be doing this stuff in the future. Having this info is really great. So thanks, Rodrigo. Thanks, everyone. We'll get back on the road here. We'll see you all next time.
Safe travels. Have a great
Bye.
season, everybody.